So Jill is the Director of Advanced Materials Technologies New Zealand Limited, and she is an expert on refractory materials, and particularly for the steel industry. And I met Jill online a couple of years ago in the Transition Engineering discussion group. And then I met Jill in person at the Carbon Transition Convergence meeting in Auckland 2 years ago. Jill has the distinction of being knowledgeable in ecological and zoological matters as well as engineering, and she has an honours degree in zoology. And her honours thesis was on energy return on energy invested in birds and birds hunting strategy. So when this came up as a matter of importance in the transition engineering discussion group, Jill was able to say, well, we know all about this. It's been known for years and years. 36 years ago, she was first dealing with EROI. And so with Jill's wide knowledge, she's made a big contribution to the transition engineering discussion group. And I've also had some other correspondence with Jill, and I've started to think of her as the fount of all useful knowledge about materials. So I think without further ado, Jill, could you start on your presentation?
So I just speak for myself. I don't consider myself an expert on lithium-ion batteries. So it was just when you asked me, and I thought, well, I'm quite a user of lithium-ion batteries, so it's probably a good idea if I find out a lot more about them, and particularly where the technology is at the moment, because it's such a fast evolving field. So anyway, I'll go to the presentation. If you can. Yeah. So lithium-ion batteries, are they, I'm just getting rid of a cat who knows how to get a feed by annoying me at terrible times. Anyway, are they the answer to transport emissions, or are they just another problematic source of concern for people in transition engineering? So next slide. Okay. So lithium-ion batteries have been a part of our life for decades, and they're invented, as I say, by English scientists, improved by American and Japanese scientists, and this collaboration won them the Nobel Prize for Chemistry. And we first started using them commercially in the Sony camcorders, which made a hell of a lot of difference to people's lives as far as they could record events easily. The difference between other batteries is they operate at a higher voltage of 3.7 volts, and they have a lower discharge rate than other batteries. As I say, I'm not a battery expert, so this is just giving you a background. They have a liquid electrolyte, which is lithium phosphate fluorides, to enable lithium to move between the cathode and the anode. They need a battery management system in order to operate safely, and that's where we've seen problems with fires. It's usually not the battery, it's usually an outside heat source which starts the reaction, and then they have a thermal runaway effect. But normally they would have a circuit which prevents any sort of thermal buildup and runaway. So when we've had battery fires, it might be in a hybrid car where you've got a combustion engine creating the heat, and we saw one of those recently where a Mercedes caught fire in Auckland recently, and it was a hybrid. And battery fires are very rare in your standard EV, which doesn't have a source of heat. They're used in almost all portable devices that we use in our laptops and cell phones, and the number of cells just in a car, you have 3,000 perhaps or more, depending if you've got a big car, and 8 in a laptop. Now, just about everyone on Earth has a mobile phone now, so they've impacted everybody's life. Normally, they use in a EV, they would normally use a lithium, nickel, manganese, cobalt oxide for the cathode, or in lithium, nickel, cobalt, aluminium oxide. Now, we normally just hear about problematic minerals, which are lithium and maybe cobalt, but those other elements are important as well. The other thing to note about them is they're not likely to be improved much from where they are, although there's still some gains to be made. So they're considered to be a mature technology. This is a simple schematic of the battery. I've added two. The cathode is a layered transition oxide, and when you're charging it, actually goes to the next one. That gives you probably a better explanation of the composition, where you've got the anode with a lithium, nickel, manganese, cobalt array, and when you're charging it, the electrons are moved to the graphite side, and on discharge, moving to the aluminium. This side. Sorry. Yeah. Oh, I can. The interesting thing about lithium-ion batteries is probably where I've concentrated more, being on, responsible engineering, is that the top sources of the elements used in lithium-ion batteries are mostly from the poor, undeveloped countries. Like lithium is, we know of the lithium triangle, which spans Argentina, Bolivia, and Chile. Nickel is predominantly found in tropical countries, like Indonesia and New Caledonia. Cobalt is a particular one that's found in Democratic Republic of Congo, and it has 70% of the reserves, and certainly the highest quality reserves. Manganese from South Africa. Graphite is one element which is particularly ignored, and the major source of graphite is in China. And copper comes from Chile. Now, because of these issues with mining in some of these countries, there's regulations that are being brought in to reduce the unintended consequences of more poor practices and poor human rights abuses. And the EU has a battery directive which stipulates the rules of origin, and it also stipulates recycling must be able to be achieved. The International Energy Agency also has a voluntary critical mineral security program. I think there'll probably be more obvious why those are needed later in the talk. So the politics of lithium-ion battery mining is quite interesting in that prior to EVs being a threat to internal combustion engines, there wasn't really much discussion about the human rights of various fuel sources. So extraction of oil, there was a little bit about human rights abuses, particularly in Nigeria, but really, apart from pollution, it wasn't like a major public issue. And so I've got two photos there. One of them, that's been distributed liberally as being an example of poor practices in a lithium mine, but it's actually a diamond mine in Canada. So, they've shown this sort of pristine environment, but it's actually got nothing to do with lithium. The bottom photo is of the Niger Delta, and this is a recent photo and shows the pollution from drilling in which there's poor pipe maintenance and oil spills, and quite common. And I think, you know, we've seen lots of programs on how the green revolution is really bad for the environment. But if you look at what's happening with oil in Africa, particularly again the Niger Delta, and this is a recent article, this is September this year, this pollution is continuing apace and there is no spotlight put on that. These communities have lost their ability to grow their food there, and there is no recompense for them. So there's terrible human rights abuses there. This is actually what lithium mining looks like. So on the left, we have a lithium mine in Bolivia, and that's an evaporative process. So you see there's no holes or anything. What they just use a lithium-rich brine and use evaporative ponds to concentrate it. On the right side, we have a lithium mine in Australia, and that is a hard rock mine. So you can see it as a deep hole in the ground, like with the other photo, but that's in Australia with Australian environmental standards. So there's two main sources of lithium, and you said there's a salt flat brines, in which salt-rich water is pumped into ponds, calcium hydroxide is added to precipitate out the magnesium and boron, and they remove that. And when it reaches a certain concentration, it's sent to a recovery facility as lithium carbonate. So that would be the process on the left of the previous slide, and it takes up a lot of space, uses quite a bit of water, but you're not digging big holes anywhere. Spodumene is a hard rock lithium, and that's the main source of lithium mined in Australia and China. And it's mined, crushed and roasted at about 400 degrees, acid leach to form, and then it is processed into lithium hydroxide. Lithium hydroxide is what is used in China to create the lithium oxide battery material. The disadvantage of that is it uses more energy. The other one, the first one uses sun, as evaporative. Anyway, when you start to look into the politics of lithium mining, it's seen as the new the new gold rush is lithium, and there's an arms race for who's going to be the winner of all of this. Whoever it is going to be expected to be the new Saudi Arabia of the world, as in a great provider of energy. They're expecting that lithium could become more important than oil, and so there's a consideration of what sort of authorities structures can be put in place to control this great rush to riches. At the moment, China is the huge player in lithium-ion batteries, and it controls the process, the mining from end to end. And as I just learned today, they have actually 93 gigafactories. Compared to Tesla's 3 gigafactories, China has 93 gigafactories building lithium-ion batteries. And so it's 77% of global battery production. Now, I presume that's not just EV batteries, that's all the batteries that we use in our portable drills and our e-bikes and scooters and everything else. And one of the ways that China has become dominant is through the Belt and Road Initiative, which is in play in Argentina, are a signatory to the Belt and Road Initiative. On the other hand, you might have Bolivia, which has heavily nationalized its extractive industries. In response to this, the US see this as a huge threat to stability and to their control of the cash around the world. Sorry about my dog is doing something. So they have established a blueprint for lithium batteries, to establish a domestic supply chain, and have established a federal consortium for advanced batteries, so that because America also has some of their lithium reserves, and so it sees itself as potentially having some control over the lithium-ion battery market, but they've got a long way to go on China. And there's also the European Battery Alliance, which is attempting to also build a domestic manufacturing, or European manufacturing facility. So, just an example, I think lithium miners have been cognizant of the need to be more environmentally friendly, in that if they're going to be seen as an alternative to oil, then they need to be seen as an environmentally friendly oil, alternative to oil. And so there's an example of a very new project called the Pilgangoora project, and that's near Port Hedland, and I'm sure you're aware, and you can see that that's in the very rich mining district of Australia, in northwest Australia. There's already a lot of infrastructure supporting mining in that area. They contracted Minviro, who are experts in battery metal life cycle assessments, to assess their project. Now, this is very recent, and I've only just seen the first sort of results from that. But what they use is there is an ISO compliant standard for battery mining and manufacture. So they use Minviro to identify sources of carbon emissions, and I think you find the results are very interesting in that, although there's no numbers on this. I'm afraid I couldn't find one with numbers on it, and I think it's only been released in the last few days. But if you look at the carbon emissions, the carbon emissions from mining, concentrating, and transport are fairly minimal. And then when you send it to China for conversion to create lithium hydroxide monohydrate, that's where all the emissions are. And a lot of that would be because of the energy sources that are used in China to create that. If you're interested in numbers, and I'm not actually that sure what all this means, but just about Chinese processing. So they need to be turned into the precursor lithium hydroxide, and then they're turned into lithium metal hydrates and nickel metal. Yeah. And this is all occurring in China. So 78% of cathode material is produced in China. And it comes at a very high environmental cost because of the poor environmental standards in some parts, and also the high reliance on coal for energy. So whilst all the criticism has been focused on mining for lithium and other elements, really the problem is actually conversion in China. And of course, that's not so transparent, also visible to Westerners. So, but that is probably where there are gains to be made environmentally with lithium-ion batteries. One of the really controversial elements is the cobalt, because it's sourced from the Democratic Republic of Cobalt. So it's 60% of cobalt, which is probably less than I thought. And the information I have is that only 10% is mined informally, and that would be by families who might be taking their kids, not schooling their kids, but using their family to mine and then sell it on. 70% of the companies mining in the Democratic Republic of Congo are actually Chinese, and they would be part of the Belt and Road Initiative of infrastructure, providing infrastructure in return for access to minerals. But the Democratic Republic of Congo is reviewing this deal because they're not sure that they're getting the best, that they're getting a really good deal out of the Chinese arrangement. And so that is under review, which I don't know what that means, but that's what's been said. On the other hand, there are battery manufacturers who are trying to minimize the use of cobalt in batteries because of the human rights issues. And some other, like as I say here, BMW announced they would source ethical mines in Australia and Morocco. But for the Congolese, I don't know if that having foreign miners exit their country is really the best result for them, as it's one of the few sources of foreign income. And I think we can do it a lot better. And there is organisations like the Fair Cobalt Alliance, which is attempting to allow the Congo to keep mining for cobalt without destroying their environment and without compromising their young people. One of the materials which is sort of ignored is graphite, and this is really interesting because it's actually one which is very hard to source. And the mines for lithium for graphite are nearly exclusively in China. But batteries require a lot of graphite. They require 70 kilograms for an average battery, and it has to be a particular grade. And graphite, it comes in various forms. Some that can be very cheap and easily accessed, but for EV batteries, it needs to be like a spherical graphite, and that can be, you need to have a flake graphite, very high quality, to create that spherical graphite. And this statement I found very interesting is that almost all lithium-ion battery manufacturing currently takes place in China because of the availability of graphite, because of the weak environmental standards and low costs. So some of the worst environmental impacts of mining are actually the graphite mines in China. And we need a sustainable source of graphite in the West. So I'm thinking that achieving a lower embodied emissions EVs rests on finding alternative sources of graphite. And that's sort of interesting for us because I'm not sure who of you are aware of our own Carbonscape, who have a pilot plant in Blenheim. And I might be a bit biased because I've worked with them for a number of years. And originally they were wanting to make an alternative to coal for steel making. And when I talked them out of that, they pivoted to making a spherical graphite from wood waste. And so they obtained sawdust, and through a fairly low temperature process, so 1200, 1300 degrees, they can make a spherical graphite using various catalysts. Now, normally, if you were to make graphite from that way, you'd need to use something like about 2700 degrees. So I think they have a fantastic product, and many battery manufacturers are interested in dealing with them. But I spoke to the CEO of the company, Ivan Williams, just a few days ago, And he said, you know, there was nothing he could announce at the moment, but there's things going on. But most likely, which is unfortunately for New Zealand, most likely this would be a licensed process that would be established overseas. Even though, you know, we have wood waste, and that was originally the idea of Carbonscape, was to utilize this wood waste and make a high value graphite or carbon product. Most likely that would be going overseas because we don't do value adding to our forest products here, which is a shame. So in a similar vein, Stora Enso in Northvolt. Stora Enso is a Finnish wood products company, enormous. It makes any sort of paper or wood products from the huge Finnish softwood resources. And Northvolt is the energy company there, and they've, in a similar vein, they're making a lignin-based graphite. So they use I'm not sure what the process is. Again, this is was announced maybe a week or so ago. But they use a not dissimilar process to Carbonscape, but I believe it's not as good, to produce graphite from Nordic forest wood. And this might be the pathway to being able to manufacture lithium-ion batteries outside of China and using renewable energy sources and not mined graphite. So will EV vehicles lower our transport emissions? Well, if you were to do transition engineering, and I was going to show a graph from it, but it's really, this field is moving so fast, it's anything that's a few years old is no longer relevant. But if you were to look at transition engineering, you know, you need to take into account the emissions profile of the product you use, and not just export it to another country. But if you work it to Kotahi or the New Zealand government, you look at our emissions as they're reported to the IPCC, and you see that 21% of our emissions come from transport, mostly private transport, and this can be greatly reduced if we transition our fleet to electric vehicles. So emissions from EVs are mostly embodied, so they have taken the number of 60% fewer emissions over its life cycle is what the Climate Change Commission consider as the fact about EVs. And so we're going to reduce our emissions by converting to EVs. But this takes time. And the target is for 50% of vehicle sales to be electric by 2030, and annual sales of EVs to be 150,000, which seems like an awful lot of cars to be, and an awful lot of resources. It might look good as a report to the IPCC, but it's not really where I think we should be heading. If you look at that figure of what the life cycle assessment, there's all sorts of different findings. I mean, there seems to be literally hundreds of life cycle assessments around EVs, and with every new one, there's a different figure. But I've just taken two here, which is first one is the Transport and Environment, and that's the European Authority. And their findings are that electric cars in Europe emit on average more than 3 times less CO2 equivalent to petrol cars, which seems to be an odd way of stating it to me. They also say that even if it's driven in Poland, and the reason they say Poland is that Poland is mostly coal-powered electricity, that still produces a better result than a internal combustion engine. And they see that as the EU transitions to renewable energy over its grid, that this situation is going to improve. Now, I think they wrote that before Ukraine was invaded and Russian sanctions were put on, and now everything's changed. But anyway, in comparison to that, I looked at this other very recent review of the life cycle assessment of electric vehicles. And this was written this is a Chinese paper, and I'm presuming they have some access to numbers from Chinese manufacturing that perhaps we don't have. And they found that the environmental benefits of EVs is highly dependent on the power mix, and that battery manufacturing has a substantial impact on the environment. So I think this possibly is a more honest assessment of EV batteries. So the common findings is that battery production is associated with a lot of carbon dioxide emission, and there's a huge range of numbers there. But I see when we have higher range vehicles with big batteries, obviously the emissions are going to be an awful lot higher. And so when we say, well, we're going to be able to have all the SUVs and twin cab utes you like, but they're just going to be EVs, then we're sort of kidding ourselves that we're reducing emissions globally. In practice, though, the field is changing so quickly. I mean, I could open an article tomorrow and there will be another advance, another measurement. And, there's a lot of work going on in this area to improve it, I would have to say. There is an ISO standard for assessing the impact of and the environmental management, which is used in assessing battery manufacture. And I've listed it there. It was last reviewed this year, and it's reviewed every 5 years. So I can imagine in 5 years' time, things are going to be completely different. So, it's such a fast evolving field that even the standards to examine it are out of date as soon as they're reviewed. The question was made about recycling. Now, recycling was something that was an issue early on. People thought that we were going to have huge loads of batteries dumped in a landfill, and that hasn't been the case. And what's happened actually is that the lifetime of batteries is way longer than expected or predicted to begin with, and I'll talk about that a bit later as to how that was achieved. But it's now considered to be on average 150,000 kilometres, which is about the lifetime of a car. So if your car gets to 150,000 kilometres, you want to replace it, you're not going to just replace the car, you replace the whole thing. But Tesla batteries, what they have a million miles. Tesla have a goal, or maybe even they achieve 1 million miles. So you might buy the Tesla body and put in the old battery. And that's because of the battery management systems. But even when they're no longer useful for a car, they can get a second life as storage, stationary storage, and people could use that in their house connected to their solar panels. And Nissan actually has an entire subsidiary devoted to finding old batteries new homes. I think now homes, but new homes. And the Amsterdam arena has 3 megawatts of power stored by old Nissan batteries. The other aspect for them is that they may be important as more intermittent renewables come online. There's more demand for stationary storage, and your batteries can be used as stationary storage. And I'll talk a bit more later about how that can be achieved. But even with all of this, we can actually recycle lithium, the lithium aspect of, or the lithium part of lithium-ion batteries. And EnviroStream in Australia do this. They dismantle the batteries, push it up to create black mass, and they export this to Korea, and it can be made back into usable battery material. One of the big game changers in New Zealand has been the establishment of ChargeNet, and ChargeNet was some motivated individuals. They paired up with the Energy Commission, EECA, and now we have 400 charging stations. They will be fast charging stations around the country. So you can basically drive anywhere on a car which doesn't have a huge range or a huge battery, and all you need is an account with ChargeNet and a token, and it just goes to your Visa, and it's all quite easy. The other one thing that's also been quite revolutionary in New Zealand has been an organisation called Flip the Fleet. And they have been devoted to, as I say, flipping the fleet, make it easier for people to decide on what EV to get, how to assess the condition of the EV and how to use it. And they've been collecting data for 5-8 years on charging regimes and battery degradation, and how to charge the battery to get the best life out of it. And organisations like this have been responsible for improving the lifespan of a battery by collecting and providing this information. So the one really good thing about EVs is that there's a whole lot of EV nerds who are just really passionate about the subject, and if you want to know anything about them or anything about a problem you might have, you can post a question and you'll get 100 answers, and people are so enthusiastic about it. That's possibly one of the really good benefits of an EV, is having such a passionate community around it. Okay. But having said all of that, I did pose a question: are we just moving our emissions offshore, and we're keeping all the problems of private vehicle ownership of needing more roads, spending more on consuming more raw materials and land and parking and keeping in traffic jams and everything else? Or can EVs be like smaller and the lithium-ion batteries be used in electrified personal mobility vehicles like scooters and e-bikes? And we happen to own 3 e-bikes without incurring huge environmental costs. So one of the plans of central government was to shift a lot of our transport to other modes of transport, and be as mostly micromobility and public transport. And we imported more electric bikes and scooters than cars in this last year, which was great. It's said that it increases patronage of public transport because people find it easier to get to the public transport hubs. And this is from a report by Becker to the government and some micromobility industries. They thought that shared paths usage will be 8 times higher with these micromobility scooters and everything else. Will be 8 times higher. So that we should be investing in these to facilitate the uptake of these. So what happened? Allocation of resources to cycling and micromobility infrastructure is unpopular. Auckland, I have some friends and contacts in local boards in Auckland, notably Jessica Rose, John Turner, who deal directly with Auckland Transport on trying to get cycling and micromobility infrastructure implemented. And they are constantly beating their head against a brick wall. So Auckland Transport will come up with a plan and it has bike lanes and, you know, nice pictures and so forth. But as soon as there's any budget constraints, the bike lanes get cut off, and this has happened. Yeah, it was quite eye-opening how anti Auckland Transport were around getting more bike lanes put in. And what we have now is a whole lot of disjointed bike paths, which I find difficult to use, and I know how to ride a bike, so they're hardly likely to encourage anybody else to ride a bike. You know, the bike path itself is fine, but then you end up in some back street or barrier, and it's not going where you want to go anyway. And then you end up on a street, so it doesn't take you away from dangerous drivers or anything like that. The other problem is that theft of e-bikes has sort of skyrocketed, and so you can't use your e-bike or scooter and to go somewhere, and it's still going to be there when you come back. The other thing is that there's a shortage of skills and labour, so even though we bought all these bikes and scooters, then it's difficult to get them repaired or to have any maintenance done because the people aren't there for that. And when Waka Kotahi analysed how these micromobility devices were being used, they found that e-scooters are actually replacing walking rather than driving. So 50% of the trips done on a scooter would have been walked otherwise. And that's not a lot of trips done on a scooter. And only 24% of micromobility trips are replacing a short car trip. So, sorry about that. One of the sort of highlights of lithium-ion batteries is that they can be used in another way than just in a car, and they can be used in a distributed energy resource. And this article, old leaf batteries 5 chargers in Waikato, so that was from yesterday. They announced that old batteries were going to be charged off-peak at night, and those charged batteries were going to be supplying car chargers in the Waikato during the day. So they can be an alternative to existing power systems or an enhancement, and that's particularly important for intermittency or something like hydro, where you could charge them at a different time, like in the middle of the night, and they can be discharged during the day during peak times and flatten the load on peak times. Yeah. So one of the barriers to doing this is that when you have a contract with an electricity provider, it's an exclusive contract. And so, you know, if we're with Meridian, we buy all our energy from Meridian, and that doesn't give us flexibility to get power from our neighbours' solar, who they could be storing it in our car battery, and, you know, we could have a trading relationship. So one of the things that actually the Green Party is looking at is establishing multiple trading relationships. And there's a trial that's in partnership with Araaki and Our Energy, where it gives you a lot more flexibility to charge batteries using the neighbour's solar panels and redistribute the energy that way. And it's done on a large scale. It could be a fantastic way of dealing with intermittent battery energy sources like wind and solar. So while there are a couple of options available, they're very small. So Tesla is investigating, or it promises that it's going to be able to have vehicle to grid ability in its new cars. So you can use the Tesla's battery as a store that is then fed back to the grid or back to your home. North Power are doing a trial of vehicle to grid in Whangarei, and unfortunately that only involves 3 leafs at the moment, but I suppose they're just testing how you would organize it and more how you would price it. So the complications are all about the trading relationships and how you pay for it. I think that technically it's not difficult to do. Mitsubishi are also doing a vehicle to house trial, and Victor have had a vehicle to house trial in Piha for a number of years, but they've always been very very minor. I think that might be all I have. Okay. So you're gonna stop hearing.
So thanks for that excellent summary, Jill. And I'll just open the floor for questions. There are a few on the chat. I could start off with one from Jeff Foley. A 2-ton car to take a 100-kilogram ape from point A to point B, when the world would be much better off if the ape just stayed home. So this is a question around essentiality and how much transport do we really need, I guess. I don't know if you have any comments about that.
Well, yeah, I sort of would stay at home, but I sense, all I can say is that there's quite a lot of resistance to that. So, it's a political problem, and we've got to convince the ape to stay at home. And if they do go out, that they take a smaller vehicle with them. And I think we've been singularly unsuccessful in doing that. I've noticed a question from Kevin about alternative lithium-ion batteries, and I thought I would have to stay away from that because that's another huge subject on itself. So, the reason lithium-ion batteries are the favoured ones is the energy density. So there's a lot of other batteries available which have got a lower environmental impact and a lower carbon emissions profile, but they're not as mobile. So I thought, okay, we'll stay away from lithium iron phosphate batteries. There's so many alternatives that could be used. I suppose the thing I find compelling about lithium ion batteries is that you can use them for mobility and storage. And if you were really clever, you could use that whole network to deal with intermittency and transport at the same time. And I think that's what Aki were trying to do with their multiple trading relationships. I think they find that it's the commercial problems, the commercial trading problems are the big barrier and not the technical aspects. So the lines companies and the energy providers all have to agree that you're going to use their lines and their power sometimes, and you're going to add your own, and the neighbour's going to use it, and all of this, and that's the complication.
Yeah. More questions from anyone?
from your hand up. Someone's got their hand up.
David Painter. You're muted, David. David, you've got your mute on.
So she's given up. I think I was going to say in response to Doug is that, you know, we have had a new mayor installed in Auckland who is sort of anti everything that we've been trying to achieve there as far as micromobility and improving cycle lanes and so forth. And as part of his campaign, he was photographed dissing a cycle lane with a motorist, and Auckland has voted him in, which is quite discouraging. So, you know, we've had a big sort of anti-micromobility vote in Auckland, which is pretty hard to swallow, really.
I could make a comment that Nelson is kind of the home of flash e-bikes, and there's lots of cargo bikes, and you see parents riding a couple of small kids to school on them. And I'd also comment, as an old long-time cyclist, that a lot of people ride e-bikes who obviously haven't ridden bikes very much, and they ride them at high speed on infrastructure which I would say is barely adequate. The paths are not wide enough and often shared paths, and in some ways I see the whole road safety issue being transferred to cycle lanes, cycleways. So I think there would be some development that would have to go on there to make it work better, but it's certainly very popular in this town.
Yeah, well, I think it would be a lot more popular here if there were better cycleways, but because it's not popular, they don't invest in cycleways. So, you know, it's a vicious circle.
Yeah.
David, there should be a thing that you can unmute yourself at the bottom of your screen somewhere, and you run your mouse around and just click on it.
Thank you very kindly. I found it. Am I okay for a question, Jill?
Yes, of course.
You mentioned Carbonscape as a New Zealand possible initiative that might be helpful. You didn't mention lithium as a byproduct from geothermal steam, which had some publicity.
Okay. That was probably a fairly minor source of lithium. I think I was concentrating on the really big sources of lithium, which are, you know, the enormous mines in Australia and enormous ponds in Bolivia. If you were going to set up a domestic manufacturing, which I wish we would, but you know, lithium from geothermal brines would certainly be a possibility. But I haven't concentrated on that because basically we're not heading in that direction. So
you're doing a bit of that in Calco, I think.
Yeah, it's not huge. I was sort of, when I was speaking to Ivan last week about Carbonscape, and he was sort of a bit negative about NZ Inc. and that they just weren't going in the direction of using their technology here. So, you know, if we have enormous forestry byproducts which are available, and, you know, the sensible thing to do would be to make them here and send them to Europe or America or whatever as an alternative to Chinese graphite. But he thought that the possibility of that was very low, and that New Zealand Inc. didn't understand the value in that.
Okay.
I would have a question about recycling. So you said that batteries are dismantled and shredded into black mass and sent to Korea. And is that the only place it's being done, or are there other places?
I think Korea is the biggest source of recycling, but also China. But it said there was an article in Forbes recently about how recycling was being hampered by lack of source material. So there isn't the used batteries available to develop recycling facility, big recycling facilities. So they might develop in the future, but at the moment we don't have the used batteries available to process.
Right.
Just one addition I'd like to make. We haven't talked about particulate emissions. In normal combustion engine vehicles, we are measuring particulates, and we always think about what's coming out of the exhaust. But there are also lots of small particles, the so-called PM2.5 particles, that come from the tires and the brake dust. And electric vehicles are equally bad in emitting those emissions. While I don't want to speak in favor of internal combustion engines, but they have, with their filtering technology, they are not emitting much on the exhaust pipe anymore, but it also comes from the tires and the brakes. And so they are coming up to a par now, the electric vehicles and the internal combustion engine vehicles. And the Europeans are quite hot on these emissions because they are actually causing lung diseases, and they're going into our bloodstreams because these are nanoparticles that are, by definition, very small. So what I
have an answer, actually.
That's another argument for electric vehicles are not the solution to many of our problems. I think we have to look more into public transport and not buy our way out of the crisis by buying more electric vehicles.
Yeah, I have an answer to those though. There was a recent study on PM2.5s from tires, and they found that the make of the tire was a huge factor. So some tires are way worse than other tires in particulate emissions. The other thing I would say about EVs is you'd actually use the brakes much less.
It's all regenerative braking.
It's all regenerative braking, so it is better in that way. So I think that there's less brake particulates from an electric vehicle.
Way less.
Way less.
On the brakes, yes, but on the tires, it's the same because the tires are still taking the load of brakes. It is through conventional braking, or through the other
transferring to the road.
Regenerative braking.
Yeah. Just looking at some of those questions.
Jill, did you come across much current research about how big a vehicle lithium-ion batteries might be practical to power?
Tesla City.
Tesla City. Yeah. Yeah, I mean, so we have a battery, I sort of didn't go into this, but, you know, the battery swapping in trucks is huge in China, and what size of those batteries are they're enormous, right?
Well, we've got some in New Zealand now too. That trucks that can do short haul or whatever, and then swap their batteries in about 6 minutes, which is really good.
Yeah, so we don't need hydrogen.
And so the thing about that is that the trucks can have a smaller battery, so they're not carrying a lot of battery around with them because they can just swap it in 5 minutes.
Yeah,
it's really quite good.
What sort of distances are we talking for short haul, out of interest?
They can easily do over 100 kilometres, up to 200, I think. It depends on the weight, that they're carrying as well.
Yeah, so I think there's 600 kilometers in Australia, so battery swapping is carried out in Australia as well. But in China, it's enormous.
So interesting when we get
I forgot about it.
Meeting.
We finished at 7.
That is green. Oh no, no problem.
Jeff has been waving to put a question.
Yeah, I mean, when I bought my Leaf, my Nissan Leaf with a 30 kilowatt hour, the total cost of the battery bank and the car production was 6 tons of carbon dioxide. And again, assuming that it would do 100,000 Ks, well, we've since done 100,000 Ks and on-sold it, and it's now coming up to nearly 200,000 Ks. So that little car has been operating at, you know, already 30 grams per kilometre, whereas my big Ford car is operating at about 300 grams per kilometre. So if you have 100% green energy production, which New Zealand is close, it's already 85%, there, and people are going to, you know, want their own private cars, then the electric car is the way to go.
Yeah, it's if people want to have their own cars, and there's just an enormous number of cars. When you think of 150,000 EVs being bought every year, that's a lot of stuff.
But it's better to buy an EV rather than an ICE.
Yeah.
So if you have to buy a car, why are we still buying ICE cars?
Yeah.
Just don't understand it.
Yeah, but like we have one car and e-bikes, and I would think, you know, that if people could make that work in their household because of public transport ability to cycle to work, you know, that is a solution. Everybody having their own 500 kilometer range EV is not a solution. But, you know, people's expectations are around, they want a huge range, they want a big car, it has to tow everything. And if they could just temper their expectations and, you know, have a Leaf and e-bikes, and, you know, if you do want to have a holiday, hire a car. If you want something that has got really long range because you're worried about it, you know, it's not that expensive to hire one. So we just don't have that mentality. And, you know, things like car sharing. What's the name of that car sharing? It's just not on people's psyche. It's sort of hoping that the next generations or younger generations are going to be more comfortable with not having a car in their garage at the instant that they want it. And I think, you know, we're going to be forced into having lower demand because our roads will be knackered from climate change or whatever. So in that way, you know, micromobility, having a bike which is less dependent on having a functional road is possibly going to be more popular just for that reason. Sorry, not too bad.
David, another question. Remember to unmute. Oh, not another question.
Oh,
I think he was off to charge Zoe.
Okay.
About reactivating a car battery, I don't think that can be done, but you can replace cells in it. So occasionally I've heard of old Nissan Leafs needing 1 or 2 cells being replaced, and that can be done for well, a few $1,000s, not that many. It's answering a question from Hannah.
Yeah.
Oh, well, there's another comment too. One of the Nissan Leaves used as a taxi in London did 800,000 Ks on the same battery.
Yeah.
So, you know, the idea of Tesla making million-mile batteries is actually not that silly. I don't think so. I don't really think recycling batteries and so on is going to be a problem.
Yeah. yeah, we're not going to have landfills full of batteries, and it's pretty obvious that the raw materials are valuable and they're recyclable, and they don't, you know, there just won't be that much of it.
Well, I don't have a question. I have a comment. We've got a Nissan Leaf. It came with 150k secondhand range. Now it's down to 100k, and it's a bit problematic. We went down to for some of our family in Raglan, and we had to recharge twice each way. You know, on the way down, twice on the way back. So yeah.
Well, what can happen there is sell it to somebody who is okay with just a short use. So if they just need it around town, cars like that are not so good for long distances anymore.
Now, also there's a second-hand market going on because of car accidents. So you can pick up a pretty good battery for about $2,000.
Really?
Yeah.
Yeah, but when they have an accident, they write off the whole car, and often the battery is quite new. So I can give you contact for a person who does that, organises that, Peter.
That could be very helpful. Yeah, thanks, Jeff.
The other good thing about batteries is, which we should think of in terms of our power supply system, we talk about battery banks so that they can cut in and look after our peak loading. Car batteries like this, you know, does have the potential. And I'm worried about line companies, because if they disappear, we'll finish up with a society with the haves having electricity and the have-nots having nothing. And I was wondering whether there's a way of allowing line companies to rent solar space on people's roofs for like $1,000 a year or something, and then have solar energy and battery banks in, you know, alongside every street mount transformer to supply homes, you know, straight into the battery bank, and then from, you know, and we're going to actually look after a whole lot of our peak loading and our vehicle transport then.
Yeah.
Yeah, I wonder if that's something that our key are looking into as part of that multiple trading relationships. So, yeah, there's a trial that's not involved with batteries at all, but there's a trial of a farmer supplying neighbours with solar power as part of that multiple trade relationship, so that the family who are not so well off can access solar power, as well as having a provider from, you know, whoever the local lines company or is. So what was I going to say? I think the other thing that I'm probably concerned about is when you start seeing things like, you know, lithium's going to be the new white gold and so forth. There's a commercial drive for people to have big vehicles so that they can sell lots, you know, sell big vehicles with huge batteries and make lots of money from people having batteries way bigger than they need. And, you know, that's the next marketing ploy, is rather than having the Ford Rangers on our television, is going to be the, you know, Tesla mega trucks or enormous, what do you say, cyber trucks and the Hummers and so forth, which was mentioned by Doug. And these are going to be the things that are marketed on our television to get people to buy them. And, you know, it's only just swapping one evil for another. And we'll end up with all the geopolitical issues related to that.
Brendan has.
Yeah, Jill, you mentioned a number of kind of common objections that people put up around pollution or filling up landfills with batteries and things. Another one is people being concerned that we'll run out of electricity if we're all charging electric vehicles. It might be worth having some comments on the video for people to pick up. Do you have any thoughts on that one?
Well, I mean, at the moment, I think we did look at that and found there was going to be a number of years before it was going to be an issue, but it's all to do with charging times. So, you know, part of the solution is what the Waikato trial was charging those batteries at night and having fast chargers, using fast chargers during the day. Whether and EVs, they all come with a timer, so you know our chargers at 2 o'clock in the morning. Whether you get so many doing that it's going to be a problem, I'm not sure. But I know in Australia the opposite is desirable, is that you charge the car from your solar during the day. So it's going to be horses for courses. And apart from the other aspect is that I think I heard it from James Shaw a few weeks ago about, you know, electricity consumption hasn't grown for like a decade. But now with EVs, it's expected to grow. And so there's a lot of contented wind farms and solar panel farms that are being built right now. And they're ready to go to meet this demand. But of course, being intermittent sources, that might mean that, you know, when we're told to charge varies. So, you know, I hope there's a communication thing around the energy providers and what resources we're using and people's charging habits.
Yeah, because we have a night rate, which is a lot cheaper. So, I mean, we're incentivized to charge our car at night before 7 o'clock.
Yeah.
So it doesn't hurt, you know, we don't charge any big times.
Okay, well, we have gone a little over our usual 1 hour slot. If there's more questions, I think we could still have a couple more questions, but failing that, thanks very much, Jill. That's been a great overview.